Good morning, everyone. Today we are excited to present our project Mobility PEI, enhancing urban walkability with data-driven insights. Next slide, please. We will start with introduction. Next slide, please. Walkability is vital to urban planning, public health, and sustainability. And walkable cities encourage physical activities, reduce traffic, and improve air quality. Despite this importance, walkability remains hard to quantify and compare across cities. And there is no transparent tools available for public evaluation. Our project addresses these gaps by developing robust and transparent framework for measuring and improving walkability. Next slide, please. The core issue is that current tools lack a unified metric to assess pedestrian environments. They often ignoring factors like land use diversity, population density, and commercial activity. Our solution is the Pedestrian Environment Index, or we can call that PEI, which combines geospatial data, provides actionable insights, and enables cross-city comparisons to support informed decision-making. Next slide, please. So last semester, the team developed a baseline methodology for the PEI, but we still face challenges. A lack of transparency exists, scalability, and no public accessibility. This semester, our objectiveness are to refine the PEI methodologies, calculation methodologies, and we will calculate a public web app for transparent analysis. And we are collaborating with Dr. Ku to broaden the applications of the PEI, and we will establish a reliable data pipeline for the future use. Next slide, please. The presentation will cover the 4 sections: methodology, how the PEI formula integrates data, technical development, and product development, which will be the workflow and creation of the web app and everything. And the results, which will be demo of web app and the data visualizations of the calculation, and also analysis and the future directions, which is the future plans to enhance and scale the PEI stuff. Next slide, please.
Yep, so I think now Albert's going to speak a bit about the methodologies we used.
Yeah, so the main things we used were OSM and census sources to calculate these 4 indices. Most of the work we actually did over this term was rewriting the indices to be compatible with Overpass API, which was used to get older data from 2013 and whatnot, because last term they didn't add that. And then once we get those 4 indices, we just normalize them and then integrate them into the PEI final index. Next slide. So the 2 main APIs we used were, the main API we used and then was OSM Overpass API. We just used that to get the landmarks and tags, which were the information used to calculate some of the indices. And then for population density, we actually used a file from the Missouri Census Data Center that basically had all the geo-IDs in the US and its population information. So using that, we just use a normal script to find the population density. So we use the census tracts and block groups from the US Bureau, the Census Bureau, which is how we got our areas and polygon coordinates. And then using those 3 things is how we made all of our indices. So yeah. Our population density index, like I said, was from those raw CSV files with the population data. All we did was a simple population divided by area formula. We used the area found from the Census Bureau GeoJSONs. So say if it was a block group GeoJSON, the GeoIDs that the MCDC returns is actually a really narrow, I think it's the smallest tract that the US offers. So basically what we do is just turn the GeoID into the ones of a block group. So we just add up all the narrow ones into the one big block group GeoID. Then we divide by that total area to find the population, the PDI of that. And then we do the same for census tracts. We make it less narrow. So yeah, that's our PDI. For our CDI, that's basically how the economic activity of the area. Using Overpass API, we get all of the, we try to retrieve commercial POIs with these tags listed here. It's a pretty short list, but that's the list that they came up with last term. So we just reuse those same tags. And then the area we use to divide the count of those POIs that comes from the US Census GeoJSON, whether that be block groups or census tracts. Then our LDI, land use diversity, is basically how much variety is in that area of land. We once again use Overpass API. We fetch all data that is tagged with land use. I know that that's really broad, but the documentation in that link shows everything that is used with or is tagged with land use. There's a lot of stuff, so just feel free to look through that to see the details. And then our entropy is calculated by that formula right there. The entropy is the LDI basically. Our IDI is just how connected all the streets are. The way we do that is we go to Overpass API and then find all of the nodes, which are basically intersections, and ways, which are streets connected to that intersection. And then we just divide that by the total area, once again, from the GeoJSONs. The intersection density is just all the intersections divided by the area. Then, Atharva, you could get the normalization.
Yeah, so essentially once we have these raw values or subindexes, so for IDI we would have just intersection densities, for LDI we would have entropies. Once we have that sort of raw data, what we decided to do that the previous semesters didn't do is to normalize it on a percentile scale. So if we have all these raw data for every city, every year, we have every single IDI we've ever had or intersection density we've ever had, we can essentially rank that, right? So now we get the tract or the census area with the highest intersection density will have a 1, and the one with the lowest will have a 0, and it's sort of a uniform distribution. So our normalization slide file essentially just takes in all these raw data and reprojects or refills in IDI values, LDI values. So now they're percentile ranks. So yeah, that's how we did normalization. And then just to calculate the PEI, we use this formula. This is exactly what the team from the previous semester did. So we had the PDI, IDI, LDI, and CDI now fully normalized. We could use this formula to create, a final PEI. In terms of actual product and technical development, let's shift more onto that now in terms of what we actually built. So this semester, our goal is essentially to create 2 main products. An interactive web app that uses, the new subindexes we created, and then also nationwide data on a census tract level to help Dr. Koo. So yeah, let's we'll talk about the technical workflow. So on the left, I know it's pretty scrambled up, but on the left we have essentially the raw files we used. So we have, as Albert said, population density CSVs. We already have that raw file. We have the census tract and census block group GeoJSONs. That's sort of the outlines of the different tracts and block groups. So to calculate PDI, the PDI.py essentially takes in the population density and the census tract or census block group GeoJSONs to create a population density. The other 3, CDI, LDI, and IDI, we use the Overpass API along with the GeoJSON to essentially fill in the GeoJSON, tell us what the commercial density is, the entropy is, or the intersection density is. From there, like I said, we put everything into a huge CSV, every population density, every commercial density we've ever calculated, we put into, PDI.csv, CDI.csv, etc. Then we normalize it like I described above. Post normalization, you finally get the 4 sub-indices and the final PEI. So yeah, and essentially everything on the right where it says pace is what we put in to pace. I mean, I'm sure Albert's going to speak about that later in the presentation, but yeah, that's essentially a high level workflow of what we did, or how the files work together. So yeah, you guys might be thinking, why create a web app? So the biggest reason for us was we set out this semester wanting to, you know, create a free, transparently calculated and accurate measure of walkability in urban areas. You know, I think a big thing about this, you know, allowing third parties to visualize and download data, you know, it's easiest way for us to spread the message of urbanism and walkability and for the data to be publicly accessible because, you know, it's more so digestible than, you know, an API, just an API, sorry. The web app's completely free. You know, it creates a link to, once we finish up our GitHub page with our documentation, etc., it'll create a link to that. So, you know, unlike WalkScore, which is, you know, the current alternative, which is extremely, you know, closed doors, we want to make it as, you know, open source and sort of transparent as possible. You know, on a broader note, having web app will also open, you know, countless doors, so we can expand our project way more than we could before. You know, we could add more features for monetizations. You know, people could request certain data. We can display it on a web app or a dashboard for them. You know, I mean, I guess if we want to charge money, we can do that as well. And, you know, with the web app, we can also integrate it into, you know, different websites, different companies for partnerships. So, you know, for example, I know Zillow uses WalkScore, so I don't know if we could partner up with because people want to see, you know, how walkable their neighborhoods are before they buy a house, stuff like that. You know, I'm sure there's loads of sort of ways we can interact with other websites and other apps. In terms of web apps tech stack, I don't want to get too technical, but you know, the data is fully stored in AWS S3 buckets. We put it on the cloud just because it's just a lot easier in terms of, you know, we can create a simple API request and then, you know, almost anyone can gather the data as opposed to it being sort of locally stored. For the actual web app structure, so the UI is fully React. We have a pretty basic JavaScript, HTML, and CSS, you know, base. And then for, you know, the website's interactive map, which we'll demo quickly later, we use Leaflet, which is, you know, the gold standard JS library for interactive web maps. So if just to sort of explain how the web app works in the background, so a user will essentially just select their configuration, so city, subindex, and year, and the JavaScript code will create an API which gathers the data for that city, subindex, and year from the AWS S3 buckets, and that returns a GeoJSON. So, you know, if the user selects Atlanta PDI 2013, we'll concatenate those together and request that specific GeoJSON. That GeoJSON is then sort of overlaid onto the Leaflet web map. And to, you know, keep our web app pretty dynamic, we keep track of a user state array. That's the array of, you know, city, subindex, and year. So anytime the user changes something, it quickly calls the API to get the most recent data for them. We also have a download button, which if you want to download the raw data, which is another thing for, you know, if anyone wants to use the data locally, it's good to have a download data button. So yeah, I think Chunlun's going to speak a bit about some work they did on the UI.
Here is our update version UI. We added some dashboard, just you can easily compare different city, the PEI, the score, and if you want to search your city, you can click which is your city, and you'll get your PEI, CDI like this, and you can easily click download the JSON file like this. You can quickly use it, and you can get a Excel file. Yeah, thanks. Next.
So the second part of our term was creating the national data for Dr. Koo. First thing we did was get the national census tract files. We just downloaded that off of the US Census Bureau website. That gave us the GeoIDs, land areas, and polygon coordinates. Then we just rewrote all the indices to be compatible with those GeoIDs and coordinates. Overpass basically just takes in the coordinates and then gets all the data from within those coordinates. So all we did to change that was take the coordinates from the census tracts instead of the block groups, and then that just provides the same data. So we could have used Pace, but the time limits would have been a hassle with checkpointing and having to restart every time that the time limit runs up. So instead, Dr. Kastner generously allowed us to use his virtual environment. We just ran it off of that. So another problem we had was that PDI, using the US Census API, trying to call 80,000 census tracts was just too much. I think they limited us. So we talked with Dr. Koo, and then that's how he showed us about the MCDC files. It made it way easier to calculate PDI. And since the only problem we had was that the GeoIDs were too narrow, all we had to do was basically make it on a more broad scale, which all you had to do was delete the last 4 digits, and that turns into census tracts instead of whatever the MCDC uses. Then we just sum all those up, use the same PDI generator. From that, all we had to do was clone the GitHub repository and then run the scripts off a Conda environment, and that would output the CSV files. It is still running, actually. The only thing that finished was CDI. PDI could be ran in just a few minutes. I think LDI, what is done with 2013 and is running on 2022 right now, and IDI is taking ages. I think it's only out of 50,000 out of 80,000 just for 1 year, and it's been running for like 5 days. So yeah, that's our progress on Dr. Ku.
Okay, so now let's share some results. Some images and stuff. I know there's a lot of text that we showed you guys, but yeah. So in terms of results, we can start off with sort of looking at the web app. I don't want to take up too much time doing this, but yeah. So I mean, you guys have seen this before, but this is essentially what it looks like. You can take one of the cities you want, the statistic you want, and this each time you select this, as I said, the API automatically gets the data and displays it on this interactive map for you. So I mean, we can look at maybe actually the PEI for 2022. This might be sort of the most relevant thing. You guys all go to tech, you sort of know that little midtown block right next to the tech sort of campus is where probably the most walkable areas of the city are. So I mean, at least in that sense, it aligns pretty nicely. And it does sort of seem as though our methodologies and our techniques work really well. So yeah, let's get back to the presentation. Again, this is live, so if anyone wants to take a pic or anything, or remember this link, then they can also use the web app for themselves.
We will test it out later for sure.
Yeah. And it's completely linked to our GitHub. So as soon as we create new changes, so when we integrate the new UI with this, or when we add new cities, it's going to automatically update by itself. So don't worry about it being an old version or anything. I think Chunlin's going to quickly speak about her UI stuff.
Yeah. Can you click this video? Yeah, here is our website like this. We have a homepage like this. You search your city and search different PDI or ER like this and download. And the second one is the dashboard. We can easily compare with different city what the PDI score and our news. What we do next week or something like this, and some score compare, and yeah, you can easily select a city and then like San Francisco. You can which different.
So I think our goal is to essentially integrate what we had before with what this is with what Chunlin did. So I mean, there's obviously a long way to go, but all the data's there, all the other stuff is there. We just need to sort of tie in the two sides of the project together. One thing I didn't show you, you can download stuff, so that'll download up there if you want to also look at the raw data. But yeah, let's keep going.
Yeah, that's all.
Yeah, and then I think Albert will speak a bit about some marketing for Dr. Ku.
Yeah, so since census tracts are on such a large scale, it's really hard to visualize when you're after normalization for the national tracts, but I completed the Dr. Ku statistics, and here's the IDI for the state of Georgia. You can see, I mean, since there's only like a few intersections in whatever census tract, and then you're dividing by a huge area, a lot of the census tracts look really similar because they're all really low numbers. But once you get to like the smaller census tracts towards the city, towards Atlanta, you can see it's getting lighter and lighter. Lighter is the higher IDI. So that's kind of the best visualization you can do, but the numbers are a lot better to look at. So if you go to the next slide. PDI does look a lot better. It's a lot easier to visualize. You can see that it kind of got more homogeneous around in Georgia. People started moving out of the cities a little more to the south. So yeah, that's the PDI comparison. So how we store the data is first in a CSV. On the top, you can see our CDI file. This is how our CSVs are formatted. You're given all of the information that we use to calculate it. So like commercial count and then the area. Then the CDI is right there. That's before it's normalized. So it's a really small value, of course, with only 2 commercial things in that census tract or block group divided by such a big area. And then on the bottom, that's our IDI GeoJSON. So that still has the same information, but this is kind of how we create the map from that data. So here is the data you just saw on the web app. We did for Atlanta on a block group scale. You can see a lot has changed in Atlanta in the past 9 years. A lot of change in the Buckhead northern area. You can see, yeah, here's our difference in PEI. It's almost everything has a positive percent change, and in that Buckhead northern Atlanta area, it's upwards to 400% difference. So yeah, it's a pretty good visualization of that. Here is, the rest of the indices laid out all together. You can, see that closer to Midtown, all of the values are better, which makes a lot of sense. So yeah, once again, the biggest change was mainly in Buckhead. Driving through this area, you can see a bunch of stuff getting put up, getting built, high rises and whatnot. And then, yeah, as a whole, Atlanta had large increases, over 100% in most areas. And then after being normalized, you can see that all of Atlanta is starting to have a similar PEI. Before in 2013, it was just like Midtown area was really high, and then everywhere else was pretty low. Now it's getting to a more homogeneous, everyone's around the same level, which is pretty good. Midtown had a large increase in PEI. We can see that with that new building next to Scheller that we're building. A lot of construction is always going on there. A lot of students always walking around, so it's looking good. And then also the southern area near the airport sees improvement. That's probably due to the big economic effect of the airport.
Now sort of let's look at some future direction in terms of, where we want this project to go, what we want to build in the future, etc. So yeah, let's quickly just short-term goals stuff, in December, maybe hopefully by December 11th. Of course, we want to finish, the national track generators for Dr. Koo. Of course, I mean, we'll see how that goes. I know one of them's taking quite a while to do. I was running on pace. Not much we can do about that, but hopefully, as soon as possible, we'll send it over to him, even if it's during break. And yeah, I mean, we have all the code right now. I talked to you about the workflow earlier on, so we can definitely add a few more cities. That's again, we're waiting for the Dr. Koo stuff to finish, then we'll start running a few more cities to get data for our web app. But yeah, keep your eyes peeled on the web app. As more stuff comes, it'll keep showing up. In terms of longer term goals, I think again, maybe this is some stuff for next semester, but we want to run the generators for I think 50 of the largest US cities, or at least US cities with populations over 100K or 200K, so the web app is as comprehensive as possible. We want to add more features to the web app. I know Shonan did a lot of great work on the UI, adding those comparison tools, creating sort of citywide scores instead of just on a census tract or block group level. So whatever sort of you saw with UI, so with Shunan's UI sort of work, we essentially want to integrate our current web app to become something like that. And of course, continuing to further enhance the statistic creation generators. I know we made big steps from previous semester in terms of, normalization, making sure cities are actually comparable between years, but there's still a few more things we can do. Yeah, so speaking on that, we performed some regular normalization where, we allowed every city every year to be comparable with each other, and we normalize everything on a uniform distribution. So something to maybe look for in the future is logarithmic normalization. I know WalkScore does this, so maybe we're picking some stuff off them. But essentially, it just means that instead of having everything normally uniformly distributed, most things will be around the 50th percentile, and then you have your big outliers in the 80s, 90s, etc. in terms of WalkScore. So yeah, or PEI for us. So yeah, potential logarithmic normalization. As we add new cities, because of the way we calculate the statistics, is going to make the statistics better because we put everything into one huge CSV and we normalize off that. So as we add more cities, the statistics will get better and better. I think a more specific one, I know Albert talked about this before, but adding more tags to the CDI. So currently, we probably don't have enough types of commercial aspects. So, you know, I think we use restaurants, shops, and a few other things, but we might want to add, you know, schools or, you know, more niche sort of locations like maybe a Topgolf. I don't know. I don't think Topgolf shows up. I remember checking that, but stuff like that, we want to add a few more tags to CDI to make it more accurate. In terms of collaboration opportunities, I know it's a big thing for us because, you know, we are pushing really to make this a public resource. So we want to collaborate with, you know, products and sites that require walkability statistics. You know, I talked about Zillow before. You know, we can create maybe customized statistics for them. You know, maybe if someone with a family wants to buy a house, they care more about walkability in the context of having kids, something like that. We can create maybe personalized statistics for these types of websites. You know, another big thing for us is, especially because we're trying to push that image of walkability, working with local governments, seeing maybe where, you know, their cities are lacking in terms of walkability and where they can maybe start to develop. And then another sort of monetization technique would be maybe developing a forecast API. So, you know, people can, you know, request data from us at a cost. You know, obviously, this larger corporation will try and make it free for like students, etc. But that's an idea in terms of monetization, how we can continue to develop the web app and collaborate in the future. In terms of broader impact and sort of what we really aim to do, you know, we set out the idea of building products, tools, and statistics that sort of help spread the message of walkability, urbanism, and so the social benefits and environmental benefits of walkable communities. We wanted to create publicly available free resources that are extremely transparent, and that's what I feel like we've done with the web app, and we're sort of going to continue to push towards doing. And yeah, you know, the big thing is providing transparency. We've said it before, walk scores are already there, but they're extremely sort of hidden, closed. You don't really know what they're doing. They're expensive as well to use their data. So you still want to break their monopoly in terms of creating transparent and really high quality urbanism statistics. So yeah, that's our presentation.